Morning, everyone, again, and I'm here happy to present another important award that ASLO gives out every year, the Yentsch-Schindler Award for young scientists. And before I go into the award, I'd like to thank the subcommittee and the nominators and the writers of the letters. Again, this is the important job. I'm just here presenting. So the Yentsch-Schindler Award is presented annually to an early career scientist who's made outstanding and balanced contributions to research, education, and society. And this year, we're really honored to present two exceptional early career scientists whose work is highlighted. And today, we only have one of them that will be on stage, but I would like to introduce the first one who couldn't make it today, and that is Yentsch-Schindler. And Yentsch-Schindler is a NERC research fellow at Bangor University in Wales, and he is receiving his award for his influential work describing the effects of climate warming on lakes worldwide, including shifts in seasonal timing, stratification, ice cover, and heat waves, in addition to his exceptional educational and outreach contributions to society and the global scientific community and early career researchers. And unfortunately, Yestin won't be here to present, and hopefully we can hear him at another ASLO meeting because his work is really very influential, and he's been cited and active actually in many of the UN IPCC committees and reports. So hopefully we'll hear from him soon. And now I'd like to actually present our second Yentsch-Schindler awardee, Dr. Mar Benavides. And personally, I have a great pleasure in presenting Mar. I've worked with her and spent time at sea with Mar, and really enjoyed the creative and stimulating atmosphere she brings into the project. Mar is today a senior research scientist at the National Oceanography Centre in Southampton at the UK, as well as a chargé de recherche at the French National Research Institute in Marseille. Mar bridges molecular biology, biogeochemistry, physical oceanography, and modeling to provide groundbreaking insights into diazotroph activity and its role, the nitrogen-fixing role in global biogeochemical cycles. She's challenged traditional assumptions about nitrogen fixation and demonstrating significant input of nitrogen fixation from the deep ocean, from coral holobionts and coastal ecosystems. Quoting from her nomination letters, "We are confident that Mar's exceptional track record, research productivity, impact, and broader societal contributions will propel her to even greater achievements for years to come. At her career stage and age, we know of few scientists who have so effectively balanced the complex demands of research, mentorship, and education." Mar, please come and accept your award.
Wow. Hello. Well, thank you. It's a great pleasure to receive this award. And I'd like to thank the awards subcommittee for choosing me, and obviously the people who nominated me. So, yes, no, the other way around, sorry. So as Ilana said, this award is given for balanced contributions through research, science training and broader societal issues. So today I thought I'd give you maybe a teaser of how I believe I've contributed to these different ones, these different aspects. But before I get started, I'd like to dedicate this award to the memory of my dad. He passed away last year. My dad was an Olympic sailor, and so it's by no coincidence that my name is Mar. It means sea in Spanish, so I've always been very related to the ocean. He was extremely supportive of every step of my career. He will follow me where the cruises were, make maps of the different cruise tracks. He will know everything about diazotrops, so I'm very sure that he will be very proud today. So you're starting with the research. So my journey in research starts with a PhD. Javier Aristegui was my supervisor. He's a professor at the University of Las Palmas de Gran Canaria in Spain. So believe it or not, I was actually a very bad student. So my grades were really low, so I could not get a PhD scholarship, but Javier gave me an opportunity. And back then, when he interviewed me on the phone, we didn't have Zoom those days, he wanted to know three main things, which were if I could speak English, if I could use a neutrino analyzer, and if I got seasick. so my answers were yes, yes, and no. So I guess that gave me the passport to become an oceanographer. So I started working on nitrogen fixation at that time in the North Atlantic. So nitrogen fixation provides supplies bioavailable nitrogen across all ecosystems in the ocean. It fuels marine food webs and export into the dark ocean. But it is also a very expensive process, metabolically speaking. So this is why traditionally we have thought that if you have other nitrogen sources around, such as nitrate, you will then dare to spend energy, you wouldn't bother to spend energy to fix nitrogen that is so expensive. So this is why most of our research has focused in low latitude regions and mostly in subtropical gyres. And this is quite well reflected in the compilation of data that we have now a bit over a decade ago. You can see that most of the data points are really constrained to the tropical and subtropical regions. But a decade later, myself and many others in this room started being curious about measuring nitrogen fixation somewhere else. So much of my research has dealt with measuring nitrogen fixation where it was kind of impossible to measure it, such as coastal upwelling systems, temperate seas, and the dark ocean. So among these things, something that struck me when I was about to finish my PhD was this publication by Hannah Farnelid, who is actually here, but she's sick in the hotel since she arrived, so it's a pity that she cannot be among us. So she sequenced nitrogenase genes from all across the surface ocean in different regions, and she reported that cyanobacteria actually make a minor contribution to the diversity of diazotrophs in the ocean, whereas non-cyanobacterial diazotrophs are much more prevalent. So something that struck me there is that cyanobacteria, they are photosynthetic, and this is through photosynthesis that they obtain their carbon and energy. But non-cyanobacterial diazotrophs, with the exception of some photoheterotrophic ones, potentially obtain these resources from organic matter. So I became very interested in looking at the interactions between organic matter and diazotrophs, either dissolved or particulate. And adding to that, if you don't need sunlight, potentially these organisms could also thrive in darker waters, in darker parts of the water column. So I started during my postdoc to measure nitrogen fixation in the Mesopelagic Ocean. And this was the very first study where I did this close to New Papua New Guinea. And what we found is mostly low but detectable nitrogen fixation rates throughout our sample set. And these were positively correlated to label DOM compounds and negatively correlated to oxygen. And when we look at the diversity, we found a great diversity of non-cyanobacterial diazotrophs, such as gamma protobacteria, deltas, everybody was there. But we also found cyanobacteria. There were trichodesmium and calotrix in as deep as 1,000 meters. So this struck me, but I was obviously not the only one to see this. At the same time, Susanna Agusti was using deep tow nets and found trichodesmium and Richelia between 2,000 and 4,000 meters across the globe during the Malespine expedition. Colleagues at NOC and my supervisor Javier sent me these pictures with finding sediment, trichodesmium in sediment traps down to 1,500 meters. So obviously this could be just sinking dead matter, but they looked quite healthy, so this was a bit suspicious. So to test this during a cruise in the Southwest Pacific, we deployed these sediment traps, and my former supervisor, Sophie Bonnet, had the brilliant idea of filling them with 15N, so that cells were, as they were sinking into the traps, would actually incubate themselves instead of bringing that up out of their pressure, out of their temperature, and trying to incubate onward. So we did this in 2 deployments, and what we found later on doing nanosims or single cell mass spectrometry on the trap material, looking at trichodesmium, we found that they were actually active, they were healthy, and this range of rates is pretty much what they actually do in the surface ocean. So this suggests that they sink fast enough sometimes to remain alive in the deep down ocean. I'm going to move to the science training now. So I don't teach, so much of my, obviously my science training goes through my students, and I've been very lucky to gather a team of brilliant students, and some of them are in the room today. These guys are brilliant and took any research idea that I had a lot farther than I could ever think. They all worked on nitrogen fixation from different aspects, including interactions with organic matter, either dissolve or particulate. We do a lot of work on the submesoscale distribution of diazotrophs in the ocean, and we have started doing a lot of work on the Indian Ocean, which is arguably one of the least known regions. So I just want to give you like some highlights of the recent work. The first one is the one of Alba. Alba is now a postdoc at Arizona University. So she was interested in looking at the impact of climate change on diazotrophic cyanobacteria. So she did these incubations where she was combining increasing temperatures with decreasing pH at the same time. And using transcriptomics, she found that if you add DOM to those incubations, these organisms tend to overexpress energy acquisition systems that allows them to cope with the harsh conditions of being warmer and more acidic. So this suggests that in future climate change scenarios, DOM may have a role in allowing these organisms to cope. Another study that came out recently is the work of Cora Horstmann. She's a postdoc now at AVI in Germany. So she looked at nitrogen fixation and diazotrophic communities in cyclonic and anticyclonic eddies of the Gulf Stream. And she found that these structures actually transport diazotrophs from the shelf waters into the Northwest Atlantic across the Gulf Stream, and that the nitrogen fixation inside these eddies is actually significantly higher than the surrounding waters, the non-eddying ocean. And last but not least is the work of Arthur Coët. He's my PhD student, and he presented this yesterday at the Polar session. So he came up with this brilliant idea of modifying a chemotaxis assay to, instead of use it with dissolved substrates, use it with particles so that you could measure colonization. So he generated these particles made of agarose and of alginate, and he could use that to document successional colonization of diazotroph from these particles over time in the Indian Ocean. And he found that particularly gamma protobacteria seem to be the faster colonizers. So now moving to the last one, broader societal issues. I believe that academic research does a service to society, and this is an example. So back in 2017, we had these huge blooms of trichodesmium in the Canary Islands, which was interesting because when I was doing my PhD there, we never found any. So this was huge, and these blooms kept on happening from somewhere between mid-June and mid-October. And they accumulated in the coast, they came to die in the coast, and this created great local alarm in the society, because this is the main source of income of these islands is tourism. So having to close your beach is not the best, so the local stakeholders were not very happy. So back then there was a lot of fuss in the local press saying that it was actually sewage, a coastal sewage discharge that was causing these blooms. So we were able to demonstrate using satellite imagery and circulation modeling, a ROMS approach, that these blooms actually generate in the open ocean and then they are washed on shore. We coupled that with incubations with clean waters and sewage waters, and we saw that nitrogen fixation was actually not significantly different between the two. So that is not to say that we want sewage in the coast, obviously, but just to maybe fight against this misinformation in local communities. And that's all. I would like to acknowledge again my team and a number of people that have been very inspiring and participated in tons of projects, but particularly like to say thanks to these 9 people, and I will name them one by one. So obviously my scientific dads, Javier Aristegui, Pepe Alvarez Salgado, and Pep Gasol, my postdoc supervisors, Lasse Riemann, Marion Voss, and Sophie Bonnet, and my brilliant collaborators, Kendra Turkubo, Claire Mahaffey, and Ilana Berman-Frank. Thank you very much.